Okay, Captain Larry W6WUH. It is Thursday, the 7th of March, I guess. 2024, if you can believe that. So yesterday I got after the list, and put the wire in for the push-to-talk relay, soldered up the input and the output coax, resoldered this shield here. It wasn't properly soldered, so I got that out, tinned it, and got that soldered properly. Put the RF sensing relative power, output power sensing unit in there, tested the components, made sure that was good. Got that connected to the green wire. On the other side, I guess I'll have to flip it over. One lead of the plate transformer that had the red-yellow lead that had to go to the center of the capacitor board. We extended that and insulated it, soldered it up. And then the B+ lead that comes over from the between the capacitor board and the diode board, we put some fiberglass insulation around that too, because it's very close to that filament transformer, and I didn't like that at all. In the tank circuit, cleaned the band switch and deoxid on the variables, checked all the mechanical connections and electrical connections in the tank circuit, final amplifier circuit. Checked the bypass caps and blocking caps and the filter chokes. Everything was good there. So the last thing we have to do is put the components on for this little ALC circuit over here, and a few resistors and capacitors, if I remember right, and put the front panel on, wire and connect up the meters, and then I think we'll be ready to start doing some testing of the power supply. So that was Wednesday, and so very, very close to being able to hook this up and test the power supply and the filament transformer. If I'd had any sense, I would have checked the plate transformer and the filament transformer before I did all this work. Just took it for granted they were good, which is not a good practice. But I didn't see any smoke, no evidence that anything was wrong there. We could still find out we got a bad bias winding in the filament transformer or something, but I think we'll be okay. Well, it's starting to look like an amplifier again. Think we'll change the jumpers to 120 volts so we can put it on the variac on the watt meter and watch it. And we'll bring it up slowly and see if everything's okay with the power supply. And meanwhile, I'm going to test the tubes with an ohm meter. Then I'll put them in here and cook the filaments with no B+ on them for a while, and we'll put the plate caps on and see what we get. What I'm going to do is plug this thing in with no tubes in it via the variac. We've got a watt meter and a voltmeter here. Got it in the low voltage position, the tune position. And what I'm going to do is bring it up slowly and watch the power draw over here, and watch the high voltage meter, and see what we get. Seeing a little current draw. Definitely seeing high voltage there. Got this thing at 50 volts, and it's showing, I'm reading this scale right, about 800 volts. It's drawing minimal current. 75 volts. You can hear the transformer humming. It's drawing about 20 watts. 1300 volts on the meter. I don't know how accurate that is. I could get out my high voltage probe. The fan is turning. Shouldn't see anything else on the other meters, and we don't. Think I will put this in the high voltage mode, and that says 1750 volts. Okay. Turn it back on again. Look at the inrush current. About 75 watts. 1400 volts, 1350 indicated. It's about 90 volts. And we're showing 1650. About 105 volts. Now we got this in the low power position, so that reduces the plate voltage. And we're showing about 1900 indicated. And we're drawing about 40 watts, which would be the bleeder resistors. So, okay, that's full tilt boogie. That's 120 volts, showing 2200 volts here in the low power position. I'm just going to let that cook for a little while. Not making a bad noises. I did give it a little lubrication. I'm going to turn this off. Watch the bleeders make it decay a little bit. Going to put it in the high power position. Then I'm just going to turn it on and watch the, I think I'll go down to nothing. Just let it go down to nothing. Bleeder resistors on the Harbox supply are a smaller value than the original Heathkit ones, I believe, so it's takes longer for the B plus to bleed down It's still showing 400 volts or so. Takes forever to get down to nothing. So even if that had only 200 volts on it, those capacitors can deliver a huge amount of current. I'd say that could potentially kill you. Certainly knock you right on your ass. Alright, so there's still some voltage showing on there. Still 50 or 100 volts there. After all this time. Takes quite a while. I would never trust those bleeder resistors. You've got to get in there and put a dead short across that thing after you've unplugged it if you want to work on it. You absolutely have to do that. Okay, what I'm going to do now is this thing's in the high power position, the high voltage position, and I'm going to watch the inrush current over here. This meter will go up to 800 watts, or about 8 amps, 7 or 8 amps. But I don't expect this to go much more than 150 watts. We'll see what it does. That's 150 watts right there. Oh boy, that was huge. That pegged the meter. I guess that noise I heard is the switch. But that pegged the meter. Hardblock increases the size of the rating, the capacity of the filter caps in here. So the total filter capacity is greater than the original design, and that increases the inrush current, which I think is why they had to design that soft start board. I've got one, and I can see that I'm going to have to wire it up and install it in this thing. Well, let's take a look at what the indicated B plus is here in the high voltage position. It's showing just about 3 kV, 2950 maybe. Who knows how accurate the meter is. And I think that's about what it's supposed to do. I'm just going to let this thing cook. We are drawing about 75 watts. 75 or 80 watts. And almost all of that is being consumed by the bleeder resistors. The transformers on their own will draw a few watts because they're not 100% efficient. But that 80 watts is being dissipated by the bleeder resistors. So I'm just going to let this run, cook in for a little bit. See if anything changes. So that's a power supply running full tilt boogie, no tube load at all. If there were tubes in there, even biased down, they would draw some power. Biased down. Um, but it's this way. There's no filament load on this thing. The filaments draw 30 amps at 5 volts. That's 150 watts right there. So put a pair of tubes in here, even with the plate clamps not connected, not drawing any plate current at all. We're going to be up to 150 and 80, 230 watts. Just sitting there on. Now this amplifier puts B plus on the tubes all the time. There's no relay that turns the B plus on and off. The tube is controlled with bias and drive alone. So that means right now we're putting a full 3,000 volts on this bypass capacitor and this blocking capacitor. So if they were going to explode, I think they'd do it now. Alright, I'm going to turn this thing off. And I guess you can see the B plus decaying here. 2,000. 1,500. $1,000. See how much slower it is at the end? 500. And it'll take quite a while to get down to supposedly 0. Still at a couple of 100 volts. Okay, it says 0, and of course I don't believe that. So this meter will go up to 1,000 volts. Let's see what it really is here. Still 50 volts there. Meter says 0. Still 50 volts there. This is why you do not trust this meter to tell you that those capacitors are discharged, because I don't know if they'll ever really discharge all the way. 27 volts, and it's been a couple of minutes. Well, what I'm going to do is look at the inrush current on this thing at the lower voltage. I think it still will be quite similar, but we'll see. Okay, we got it in the tune position, so that's 2,000 instead of 3,000. And let's look at the watt meter over here and see what it does. I bet it pegs it again. Went up to 800. It was, it absolutely pegged it last time. And that says 2,300 volts. When you put it in the high voltage position, the watt meter kicked up to about 300 watts. So it's quite a little spike there. Okay, so I'm pretty happy with that. I was real careful when I built the Harbach boards up. I tested all of the diodes individually before they went in, and I don't know if I tested the capacitors or not. I can't remember now. Probably didn't. But everything seems to be just fine. I'm glad to see that the metering is working correctly, and I think the power draw is normal. Well, what I'm going to do now is unplug this thing, short out the power supply so that I'm sure I'm not going to get electrocuted. Then I've got two iMac tubes. I think I will test them for shorts with the ohmmeter, and then I'm going to put them in one at a time and run them, make sure the filaments are okay, and then we'll look at testing the tubes further after we've done that much. So that's what I'm going to do now.